Hello, everyone, and welcome to episode 5 of Clay Loves Logic, where on this channel I solve logic-based Sudokus and puzzles, anything interesting like that. As always, I'll put the link to this puzzle in the description so you can try it if you'd like. But for now, let's turn our attention to Roadblocks by James Sinclair. Now, there's a lot of rules in this puzzle, so let's start with everybody's favorite rule. Normal Sudoku rules apply. We have to put the digits 1 to 9 in every box, in every row, and in every column. Now, we also have the German whispers rule. So along green lines, adjacent digits have to have a difference of 5, which means we can never put a 5 in a German whispers line. Because what would you put on the other end of it? 0 or 10, neither of which are valid. So for example, if this is a 3, this would have to be an 8 or a 9, and this would have to be an 8 or a 9. Then this would have to be 4, 3, 2, 1, etc. And then we have our favorite rules, my favorite rules, X and V constraints. So digits with V, sum to 5, digits with an X between them, sum to 10. So this could be 4, 1, and 6. That would be valid. We get, this one is what's interesting. Digits in a shaded square must be even, and there is a whole bunch of them. And digits with a shaded circle must be odd, and there's also a whole bunch of them. So let's go ahead and pencil mark these in for now, 2, 4, 6, 8. None of these are going to be 4, and maybe this one, but none of these are going to be 4, and we can just take 4 out of all of them because the only digit that's 5 different from 4 is 9. And if these are all odd, or if these are all even, then you couldn't put a 9 on any of them. So we can look at this here and we can put 1, 3, 7, and 9. Well, of course, 5 is an odd digit. Can't have a 5 on German Whisper, so we don't need to put it in. We can pencil in our 4 cages, or our 5 cages, or cages, our XV pairs. Okay, let's start looking at the puzzle. I want to look at box 3 briefly and ask you, where could we put a 5? And it can't be on an X cage because the only digit that sums to 10 using a 5 is a 5. So there's 5 here. And there could be a 5 in any of these spots, 5 anywhere there. But we can look to the same thing here. Where would a 5 go? It could only go there or there. So that's where the 5s are going to live. And then if we look at this one, not terribly interesting. What is interesting, if we look at box 8, we can only have a 5 in the bottom because this can't be a 5. So one of those two is a 5, one of these 3 is a 5, one of those 2 is a 5. So let's start looking at this German Whisper. And the question I have is, can we ever have a 6 on this? And again, we can't actually. Because whereas 4 only has one option, and that's 9, 6 is the same. 6 has to have a 1. So actually, this entire German Whisper line is from 2 and 8. Wow. Okay. So we can remove 2 and 8 from those right away. Wow. Okay. So when this starts with a 4 or a 6, it's going to immediately go to either a 1 or a 9. Okay, well, we can take 2 out of this, 3 out of the inverse, 8 out of here. Wow. Oh, and actually 2, 8 here as well. So that can never be 2. That can never be 3. This is always a 1, 4. And that's always going to be a 6, 9. Oh, and that's how we start. This is always going to be a 1, 4. So this is a 6. 6 means this is a 1. 1 means this is not a 1 or a 3. This is not a 7 or a 9. This is not a 1 or a 3. This is not a 7 or a 9. This is not a 1 or a 3. This is not a 7 or a 9. This is not a 1 or a 3. This is not a 7 or a 9. And this is not a 1 or a 3. This is only a 9. And this is a 4. Very, very fun start to this puzzle. 4 in here means we remove a 4 and a 1 from that. It has to be a 2-3 pair. 2-3 pair means we remove 6, 9. Wow, interesting. And this 2-3 sees this 1-3. This is now a 1. Huh. Wow. We have to be able to solve this now. 1, 2, this is a 3-7 pair. Has to be. What else could it be? It's nothing. Because what else is going to be a 1, 2, 3, 4, 5, 6? Yeah, this is a 5-6 pair. This is now not a 3. It's only a 1 because there's a 3-7 here. Okay, 2, 3, 7, 8, 7, 9, 1, 3. Okay. Where should we look next? Oh, we can look right here. There's a 3-7 pair. This has to be an 8. 8, 2, 3. That's interesting because why? Oh, this is a 7. There's a 9 right there. It sees it. This is now a 9. This can still be a 1 or a 3. But actually, if this is a 1 or a 3, it doesn't matter what. This has to be a 9, right? Because how could this be a 7? You need a 3 on one side of it. And yeah, you can't have double 1 here. So this is always a 9. And this could still be a 7 if this is a 1. I don't know yet. We'll figure that out later. What digits are we missing in the bottom? Actually, that's interesting. 9 can't go here because there's a 9 in the box. 9 can't go there. This is a naked single. It is a 9. Now we're getting somewhere close on the bottom. Oh, there's a 1 right here. This is a 3. This is a 1. What are we missing on the bottom then? We're missing 1, 2, 3. We're missing 4, 5, 7. And we can't do any better just yet, but that's okay. We can probably solve this now. 1, 2. I think this is just going to have to be 3, 7. And this is going to have to be 4, 5. Yeah. And 3, 7 is not going to resolve this. 4, 5 is not going to resolve anything there. Okay, that's fine. I wish I knew how we could start this, but I don't yet. What do we need in here? 1, 2, 3, 4. We need a 5, a 6, and an 8. 5, 6, 8. This can't be 8. There's an 8 there. There's always an 8 here. Oh, look at that. That's how we can start it. There's an 8 in the bottom here. 2, 8. This one's going to be really easy to solve because it can only be from 2 and 8. So it'll always just oscillate the whole way through. And that's going to do a lot. This could never be 2, 3 anymore. It has to be 1, 4. Don't know which way yet. But when we need a low digit to help us get to 10, and it's not 1, 2, or 4, it can only be 3 and 7. That's not going to resolve anything yet, but it is putting a little bit of pressure in here now. We ask ourselves where an 8 goes, can only go in one of 2 places. And that is going to put an 8 here. And now if we look at where an 8 can go here, it needs to be, oh, can't be here anymore. This is an 8. This is an 8. Okay, now what? Is that all the 8s? No, probably we don't have one up here yet, but we will. That's an 8. And the 8s are solved. Okay, let's turn our attention to what precisely? Couldn't tell you just yet. I guess what do we need here? We need a 9. Can't go there, can't go there. That's a 9. And that's going to give us a 9 in one of 2 spaces here. And what do we get for 9s here? Fine. 9 has to be up here. And 9 has to be here or here. This is 9. Okay, what about ones? We have a lot of ones. One, it's just Sudoku says that's a 1. What else? We know there's a 1 down here, which means, oh, okay. Hey, that's interesting. Look, we know this is a 1-4 pair. So in this box, 1's in the bottom. Now in this box, 1 has to be in this row, but we have a 1-4 pair here, and this is a 1. So that's a 1. And then we get a 1 somewhere in the middle, and that's going to be all the ones in their almost right places. Naked single 2 here. Same naked single 2. That's going to be a 2. Does that solve the 2? 1, 2, 3, 4, 5, 6, 7. That's all the 2s. Okay, 3s. We need, oh, that's been maybe available for ages. That's a 7. That's a 3. 3s. This is now going to have to be a 3 because we have a 3-7 pair there. We know there's a 3-7 pair here, which means in this box, 3 is somewhere on the bottom. And then in this last box, we have a 3-7 here, 3-7 here. Not sure yet. Well, there's 2 more digits we need in this central box, and a 1, 2, 3, 4. We need a 5 and a 6. I don't immediately see anything that will solve that right away. 5, 6s. Yeah, I don't see them. What do we need here? 1, 2, 3. We need a 4, 5, and 6. 4, 5, and 6. And that means that one of these is a 4. We know there's a 4 here. Okay. What else do we need? Let's look at this row. 1, 2, 3. We need a 4, a 5, and a 6 left. And if we look at this box, 4 and 6 are spoken for. This is a 5. None of these are 5s. This is a 6. None of these are 6s. This is a 5. This is a 4. This is a 5. This is a 4. Neither of these are 5 anymore. So, oh, okay, well, there's a 4 here. One of these is a 4. We need a 4 somewhere in this row. Can't be there. That's a 4. This is now a 5-7 pair. And we now need a 4 and a 6. And that resolves as well. This is a 4. This is a 6. Left over 1, 2, 3, 4, 5, 6. This is going to be a 7 down here. We're going to have 1, 2, 3, 4, 5. We're going to have a 6. That is not going to do anything just yet. Oh, this has probably been available for ages. This being a 4. 1, 4, 9. Neither of these are 9 anymore. Is this the only spot that can be a 5 now? It is. So that's a 5. That's a 5. That's a 6. 4, 5. Where do we put 6? Don't know just yet. We need 3 digits here. What do we need? We need 1, 2. So we need a 3. 4. We need 6. And we need 7. Now this can't be 6. So the 6 is always over here. I don't think there's any other restriction. I'm not seeing any. This is then the same. This is 3, 6, and 7, and I think all those are valid. I don't see any reason why that couldn't be a 3, 6, or a 7 right now. If we look up here, we need 4, 5, 6, 9. 4, 5, 6, and 9. 4, 5 are already in here. This is a 6, 9 pair. This is a 5. This is a 4. This is a 5. This is going to be a 6. This is a 7. This is a 5. This is a 3. This is a 7. 7. Now this can't be a 6 anymore. It's a 3, 7 pair. And do we know anything more about it? Not quite, I don't think. Okay. Oh, this is done. This 6 gives us a 9, gives us a 6. Up here, maybe we have a 3, 7 pair, and we're looking to add 4, which can't be here. This is 4 because of this 4. Gives us the 9. Here we need, oh, this can't be a 1 anymore, so that's a 1. Neither of these pencil marks are valid. This can only be from 3, 6, and 7, and it can't be 6. So it can only be 3 or 7. So this is 6. This is now a 3, 7 pair. So is this. And in the top of the grid, we are going to need we're going to need a 3. We're going to need a 5, 6, and a 7. Now this can't be, oh, actually, you know what? We have a 1 here. This is a 4. This is a 1. And then this is a naked single. This is just 1, 2, 3, 4, 5. This is a 6. All it can be. This is going to be not 3 or 6. Wait. This is a 7. This is a 3. This is a 7. This is a 3. This is a 7. This is a 3. This is a 7. And we need 3 and 5. So this is a 5. This is a 3. Okay. And that solves the puzzle. 17 minutes, 47 seconds. You solved the puzzle. The solution is correct. Do you like the puzzle? Yes, I do. Roadblocks by James Sinclair. Fun puzzle. I feel like I'm a little tired today, and I was looking at the wrong places at the wrong times and solving things more traditionally Sudoku based rather than using some of the clues I gave. I might have missed a couple easy ones. People might have been screaming at me saying, no, look over there. But nonetheless, good solve, happy with it. And I will see everybody in the next video. Thanks for watching.